Since much of the focus of the reduce methodology and SMED is focused on internal and external activities, cleaning up the process can be broken down into two areas: improve or eliminate the remaining external activities and improving internal activities. Because much of this section borrows from the practical approaches shared by Dr. Shingo in his book, A Revolution in Manufacturing, the SMED System, we will break them down into different lectures for your understanding. Let's get started. One of the first things you can do to clean up or streamline your changeovers is to clean up external processes that you may not always consider. For example, retrieving a tool is a natural part of the process, but does not add value and consequently waste time. When improving or eliminating the remaining external activities in your external setup, one of the largest opportunities you will find is in the transportation and storage of tooling, materials, parts, and information. Looking around for hours to find the right equipment will not add value for anyone. One effective system that can be used to improve the external transportation and storage of materials is the 5S system. The 5S system is a visual workplace management system that promotes safety, efficiency, and teamwork while making abnormalities visible. As you use the 5S system to streamline the storage of materials, tools, and equipment, keep these three questions in mind. What is the best place to put these items for easy access? How can these items be stored so that they are ready for the next use? Do we need to keep inventory on hand? If so, how much? As you consider these questions, you may also wish to map the flow of items with a spaghetti diagram or flowchart, review distances, and ensure that items are at ergonomic levels and with safety in mind. Keep in mind that various improvement tools can be used to reduce or eliminate remaining waste in your external process. As you establish better storage and retrieval practices, you will find that external activities can be reduced to 9 minutes or less. After every possible form of waste has been squeezed out of the external activities, improvement of the internal activities can take place. This can be a bit more tricky than improving external setup activities and oftentimes requires engineering assistance, investments, and a little bit of planning. Nonetheless, there are some things that you can do which will bring your times into the single-digit time frame. The 4 techniques that can further reduce your setup or changeover times are: first, converting sequential steps to parallel steps where possible. Second, use of clamps that are functional. Third, eliminating any and all adjustments, and last but not least, mechanization. As with any other portion of a changeover, there are some powerful methods that Dr. Shingo shares more about in his book, A Revolution in Manufacturing, the SMED System. We will look into each of these techniques as we drive time out of and improve our internal setup activity. See you in the next lecture. You've now looked at every aspect of your setup, from internal to external activities to standardization and beyond. But you still want to squeeze some time out of your changeover. This is where mechanization may come in handy. To mechanize is to equip with machinery. Mechanization is a last resort and should only be performed when every possible effort has been made to improve your setup times. You may be wondering, Why? There are two main reasons outlined by Dr. Shingo and supported by many different experienced professionals. Mechanization will not reduce your setup time by a substantial amount. Rather, if every effort has first been made to improve the setup process, you may be able to shave another minute off of your setup time. Mechanizing will not improve the process, only a portion of the process. While it is true that mechanizing can improve a task or any activity within your changeover and may shave additional time, it is also true that if the process is poorly designed, mechanizing alone will not be able to correct the poorly designed changeover process and the operations found therein. With these two reasons in mind, mechanization is oftentimes necessary when large equipment or heavy items are part of a setup. Some practical techniques that can be used are using forklifts to move heavy items and insert tooling, tightening and loosening items, and use of moving bolsters. As you make decisions on what to mechanize and what not to mechanize, be sure that appropriate cost to benefit analysis is performed. Mechanization will in many cases require an investment and may not be worth the amount of improvement you will get. So, be sure that you put hard work and determination into your improvement before you mechanize. It may seem like nuts and bolts are needed to complete your internal setup activities. In this lecture, we will dig into a few of Shigeo Shingo's legendary tips from the book A Revolution in Manufacturing, the SMED System. Nuts and bolts are cheap. You can get them everywhere. They hold items on and do the trick. With a few exceptions, of course. They take time to install, they get lost, they are mismatched, they can get stuck, and every turn except the last one is waste. As we learned earlier in the course, the purpose of a nut, bolt, or any attaching device is to secure and unfasten. This means that if a bolt has 10 threads on it, 9 of the turns it takes to securely fasten the bolt are waste, and only the first or the last is actually needed. The reduce methodology borrows from SMED with functional clamping systems and devices, instead of nuts and bolts. These devices not only save wasted time and energy, but they also can be custom made and attached to machines or information flow so that tooling, materials, and information do not get lost. There are 3 main functional clamping systems that we will introduce in this lecture: one-turn methods, single motion methods, and interlocking methods. One-turn methods, as the name implies, seek to eliminate the over-processing that is inherent in many nuts and bolts and screws by creating a one-turn item. This is a single motion item. These items require one motion to secure an item, such as a switch that is flipped or a button that is pushed. The final functional clamping method is the interlocking devices. These items generally slide into place to secure items. As you can tell, these 3 options are great alternatives to the long process of finding nuts and bolts, acquiring tools, and laboriously securing them during internal activity. You can find more details about these functional clamping devices and methods in the handouts of your course materials. See you in the next lecture. One of the first first things we can do to further clean up our internal setup activities is to analyze and implement parallel operations. The word sequential is defined in one way as following. In the case of your setup, steps are often performed sequentially or in a sequence, one following another. When this occurs, it requires us to wait until the previous step is complete before moving on to the next step. Looking at our Indy example again, we see this sequential activity as the pit team works on the front right tire, first banging profusely to remove the tire, then walking to pick the tire up, and finally placing the tire back on while again banging to tighten the tire. Parallel operations, on the other hand, can do activities in parallel or at the same time as others. For example, in the 2013 Melbourne pit stop, we see a pit team member run up with a tire in hand. We also see an individual at a specific marking point ready to work on the tire. To his right, another individual. As the wheelman gets the tire off, the individual to the right takes the tire and the individual to the left places the new tire on, while the wheelman prepares to tighten the tire. As you can see, parallel operations divide the setup tasks between more than one person, and oftentimes activities that are parallel processed are performed in unison with one another. This can help reduce an internal setup to below the 1 minute mark. One very important tool that is used when operations are converted from sequential to parallel is a procedural chart or a process chart. A procedural chart can be a simple template that allows you to document the sequence of tasks that need to occur at a very granular level. It also tracks the time of each step in the setup, the cumulative time at each phase, and should show whether the activity was internal or external. In the template, there is also a notes column where you can jot down your observations. To the right of the notes are many small boxes. These boxes represent the time of each step and whether the activity is internal or external. Each of these steps also show whether an activity can be performed in parallel or must be performed sequentially. The template is available in the resource section of the course for download. Using a procedural chart not only gives you a living document to see the setup and make improvements, but it also helps train employees and keep the changeover safe and consistent. When combined with visuals such as lights and other sensory devices like sounds, this can trigger the completion of one step and the beginning of another. As you see an opportunity to improve, you should update and standardize the chart. This will give you a living document that people can look to and discover more improvements as revelation occurs. Keep in mind that this concept of parallel processing can occur in many portions of your process. So, be sure to look for opportunities where you can make the most of the resources you have. Now let's move on to some more powerful internal setup improvements. As was already mentioned, trial runs and adjustments can account for about 50% of your traditional setup time. As such, eliminating this time will yield a great deal of savings on your setups. To eliminate these tasks, you will need to look to the earlier phases of your setup and adjust and standardize how these activities are performed. There are three practical techniques shared in the book, A Revolution in Manufacturing, the SMED system, that are used to eliminate adjustment. use of numerical scales, and standardization of settings, making visual center lines and reference planes or points, and use of the least common multiple system. Intuition and experience can be a great blessing in a lot of different situations. However, in most situations, neither intuition nor experience will work identically every single time. Numerical values will create consistency. If you know that the oven should be set at 350 degrees to cook your favorite meal, the setup will be the same every single time you change over the oven. Whether it is distance, temperature, pressure, or torque, you need to standardize your numerical settings. To start, be sure that the settings are visible. This is often referred to as a graduated scale. Without this, you're only guessing. Many machines or software applications, in the case of information systems, do not have visible reference planes, points, or center lines. This makes it difficult to repeat applications or production without many different adjustments and a trial and error approach. Without a visible reference to the exact position of your needs, you are again basing your placement on intuition. By making these references and lines visible, it makes the setup much quicker and easier to perform. If a template can be made, this may be another option. Remember, we don't want to get closer to the mark, we want to eliminate adjustment. You may want to consider the following question. In my setup or changeover, how can I make center lines and reference points visible so that I no longer need to make adjustments? As you make centering lines and reference points visible in your setup operations, you will find that the internal setup activities will become much more effective, and you will be able to eliminate trial runs and excessive adjustments. Leave the mechanism alone and modify only the function is the slogan in the least common multiple. The least common multiple is a concept taught in arithmetic applications today. Dr. Shigeo Shingo shares in his book, A Revolution in Manufacturing, the SMED system. The name refers to the notion of providing a number of mechanisms corresponding to the least common multiple of various operating conditions. There are many examples of the least common multiple system. Success with its application depends on two fundamental principles. Establish and make settings, not adjustments. Modify the functions only. Leave the mechanisms alone. These techniques will give you a starting point to eliminate adjustments in your setup operations. But keep in mind, no adjustments will be eliminated if you do not standardize your success. Remember, eliminating adjustments could eliminate up to 50% of your time spent on setups. So be creative and innovative and find ways to make trial and error extinct.